Hey there, ladies and gents. Okay, so this will be the first of like a 3 or 4 part um, review guide key, if you were. So I'll post a key that I'm making right now as I'm talking. But again, to get the full effect, you're probably watching this video so we can hear the stuff I'm talking through as well. So here's the thing about this test coming up. It's not really going to be a terrible test as long as you're preparing yourself. This kind of paper version is provided as a supplement to what we're doing in Khan Academy. Those 7, 8 recommendations in Khan Academy that have to do with translations are probably your primary thing. In other words, if you can do those recommendations, this test is actually frightfully easy. But if not, well, that's the work you got to put in. So if you're here, you want this extra stuff, so let's get to it. So the first part, let's talk about some vocabulary, terms, and concepts. These are just vocabulary stuff that we were using while we are talking about these transformations. So it's worth it to go through, make sure you understand what each one means, what it looks like, and where you use it. So that's what we're going to talk about. So a vector. A vector is nothing more than a distance and a direction. That's all it is. Distance plus direction. Okay. We see that in the concepts, or in the context of transformations, specifically translations. Okay, and then a nice example would be when you're actually translating an object, right? So if you have, let's back up. If you have this triangle, and then you're translating it somewhere else, let's say to here, the vectors are actually going to be what you're translating upon. So like this vector right here, and this vector right here, and this vector right here is what you're using to translate the object up. These guys are the vectors. Okay? So that's how you'll see vectors play out. Okay, perpendicular bisectors. Perpendicular bisector, let's go green. Okay, so perpendicular bisector is just a line that cuts another in two at a right angle. Okay? We'll see these in the context of reflections. Okay, so if you want a nice little example here, let's set up a reflection. Let's say I'm reflecting that triangle over that line. The perpendicular bisector is actually the same thing as a line of reflection. That's pretty bad. Let's try it again. That's a little better. Okay, so the perpendicular bisector. There we go. Okay. Perpendicular bisector is the line of reflection. Okay, so when you're looking at this guy, okay, we have this line that connects the pre-image and the image. That's been perpendicularly bisected. Here's this one again, and the one at the bottom as well. Okay, so perpendicular bisectors you see in the context of reflections, and there you have it. All right, let's talk center rotation. Uh, center rotation is the point that does not move in a reflection. And that is also equidistant from all points. Okay, so the context here is going to be rotation, of course. Okay, so how you'll see that play out? Well, if you have, let's say, this point here that I'm rotating, it's like here, the center of rotation is going to be the point that is equidistant from both of them. Now, this also forms the angle of rotation. Okay, but in the end, it's kind of like where all the action is happening. All right, let's keep moving. Angle of rotation. Well, angle of rotation, you can kind of use the same picture. It's the angle at which a point is rotating. Okay, so the context in this case is, of course, rotation. Okay, so I'm not going to draw a new picture. I'm just going to draw a picture to my old one. The angle is defined by the image, center, pre-image, which means it's defined through that point, and that point. Okay, that's how you find your angle. All right, here's our new guy, center dilation. Okay, so center dilation is the point. It's going to be the point at which the lines of dilation start. And just like a center rotation, it doesn't move in a dilation. Okay, so let's get a picture in here, and I'm going to be kind of a squeeze for room here. But if I have this shape, let's say I want to dilate it. The center dilation is where the kind of whole action starts. The lines of dilation come out from the center dilation, and then you have your shape. Okay, so the center dilation is right there. All right. So we have quite a form here to go, so please bear with me. I'm sorry it's getting kind of long, but that's how this is. K factor. So the K factor is the scale factor in a dilation. In other words, it's how many times bigger or smaller. Okay, the context here is dilation. In the picture, I can give you, I'm just going to recycle this one here. Like if that's 2, that's 4, that's 3, that's 6, that's 2, that's 4, say 3 and 6 again. The K factor, and let's assume we're getting bigger here, would be 6 divided by 3 or 4 divided by 2, which gives you an indication how to find it. You're dividing sides. But in the end, these are just both 2, so the K factor is 2. All right, so now we have some things that are not specific to any one of these transformations, but just things you have to know. The origin is a point 0, 0 in the middle of the coordinate plane. Okay, so if I have this guy, that is the origin. Okay, map, the term map means to move to a copy. Okay, so like example, if I wanted to map ABC, I might make it something like this, where this is A prime, this is B prime, and this is C prime. So that's all it means to map, is to map onto a copy of itself, like transform. Okay, so map onto itself means that it's not moving. Okay, so if I say I have triangle, let's have a point. If I say point 2, 3 maps onto itself, that means it's not moving, everything else is. Okay? So maps onto itself is like a dead giveaway for being like a center of a rotation or a line of rotation. Oh, sorry, I got distracted there. Center rotation or center of dilation. This is usually a dead giveaway for it being those centers. Quadrant 1, 2, 3, 4. Okay, this is important. This should be prior knowledge, but it came up the other day that someone didn't know these. So this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. There's not much to say about this other than if you notice, like if you accept this to be y and x, this is like plus x plus y because they're both positive. This is minus xy because it's negative. This is minus x minus y because it's negative all over there. Left, right, up, and down. And this is, of course, positive x and then negative y. So just please memorize those quadrants if you never remember. This is new information, memorize it. Hopefully this is just a brush up, okay? Let's keep going. So we have translation. And so a translation is just a rigid motion or like a slide is a good way to put that. Reflection is also rigid motion. This is a turn. Rotation is again rigid. Oh, I'm sorry, I messed up. I'm sorry, I wasn't paying attention. So this is a rigid motion and it's a flip. This is a rigid motion, that's a turn. This is probably dilation. Yep, so it's a non-rigid. Okay, this is like a blow up. Or a shrink. Now we can add some more stuff to this, and it might be worth it to do so. So this is changing by addition and subtraction. This is changing by rearranging and opposites. This is also changing by rearranging and opposites. Now I am referring to the x and y values, of course. And then this is changing by multiplication. Okay, so in other words, for a translation, this would be like xy going to like x plus a, y plus b. For a reflection and a rotation, this would be like xy going to like negative xy, or something like xy going to negative y comma x. So you're using the same x and y values, you're just kind of moving them around. And dilation, this is xy going to xk, yk. Okay, last thing, let's talk some triangles here. Acute, that just means all angles that are less than 90. So something like this would be acute, where this is like 50, this is like 45, and this would be like 45. All three of those angles are less than 90 degrees. That makes it the thing an acute triangle. Isosceles just means two sides congruent. There are acute isosceles, there are obtuse isosceles, there are right isosceles. The only requisite is that you have two sides that are the same. Okay, so let's talk about right. So that means one right angle. So that's a right triangle. Obtuse means one angle bigger than 90. Okay, so picture-wise, I would look for something like this. That's a typical obtuse triangle where this is like 120. So this would be like 30 and 30. Scalene triangles, that means no sides or angles are the same. Okay, so this is probably the most common type of triangle. It's just like the random triangle. So you have three different sides, and then you also have three different angles. So like this could be like 100, this could be like 100 and 100, man. Okay, that's like 100. This is like 50, and this is like 30. Like that's a classic scalene triangle. So just a little brush up on triangle types. Okay, I'm going to end this pretty long already, so I'm going to end this part here. I'll see you guys in part 2 if you want to.